For today's lesson, we will be discussing about distance formula. The distance formula is used whenever we need to find the distance between any 2 points in the coordinate plane. This will also help us to determine the length of a segment. So if A, which is noted as x sub 1, y sub 1, and B, which is x sub 2 and y sub 2, are any 2 points on the coordinate plane, then AB will be equal to square root of x sub 2 minus x sub 1 squared plus y sub 2 minus y sub 1 squared. So we will use this formula again if we want to get the distance between any 2 points on the coordinate plane. So for example, we need to find the distance between point P and point Q, which are 4, 3, and 9, 15. Now again, the formula here to get PQ is you have square root of x sub 2 minus x sub 1, then squared, plus y sub 2 minus y sub 1, then squared. Now we have to identify which will be point 1 and which will be point 2. Now let's just have P as our first point, so x sub 1, then y sub 1. Then Q will be our second point, so x sub 2, y sub 2. Then all you have to do now is to substitute the values. So you have PQ equals, then subtract x sub 2 and x sub 1. So that is 9 minus 4 and squared plus then 15 minus 3. Then just simplify this. So square root of, then 9 minus 4 is 5. Then squared plus, then we have here 12 squared. Then this will become 25 plus 144. Or if we simplify this one, square root of 169. Then just get the square root of 169, then we will have PQ equal to 13, then let's just write units. So that means the distance between point P and point Q is 13 units. Next example is that, let's say the vertices of triangle HOT are, we have H, which is 4, 5. We have O, which is 1, 1. And T, which is 5, negative 2. Now we have to show that this triangle is isosceles triangle. So if we will plot these points on the Cartesian plane, so we have here this figure. Now we have to keep in mind that an isosceles triangle must have at least 2 congruent sides. So what we will do here is we will get the distance between pair of points, and we need to show that at least 2 of them have the same length or they just have the same distance. So let's start with HO. So HO is equal to, then get the square root of, I will make H as the first point and then O as the second point. So I have here 1 minus 4 squared plus 1 minus 5 squared. Then square root of, then this is negative 3 squared plus, then this one is negative 4, then squared. Square root of, then you have 9 plus 16. This one is square root of 25, or HO now is equal to 5 units. So we already have the first side, which is HO. So this one is 5 units. So we need to solve for the next one. Let's have OT. So OT is equal to, then I will be using O as the first point and T as the second point. So 5 minus 1 squared plus then negative 2 minus 1 squared equals, then this one now is 4 squared plus negative 3 squared equals 16 plus 9, or this is square root of 25. Then we now have OT, which is equal to 5 units. So we again have the second segment or second distance, which is OT. So this one is 5 units. And lastly, we will be solving for HT. So we have to get the distance now between point H and point T to get HT. So H now will be my first point and T is the second point. So x sub 2 now is 5 minus x sub 1, which is 4, then squared plus, then y sub 2 is negative 2 minus y sub 1, which is 5, then squared. So square root of, then 5 minus 4 is 1, then squared, plus we have negative 7 squared. 2, then you have 1, plus this is 49. Simplifying this, square root of 50. Then we can simplify this, so 25 times 2. So that makes HT equal to 5 square root of 2 units. So HT now is 5 square root of 2 units. Now, since two sides or two segments have the same length, then we can conclude that triangle HOT is an isosceles triangle. So that's it for today. I hope you learned something about the distance formula and see you next time.